So here when there is a magnet, when there is a relative motion between the magnet and a wire, then current is induced in the wire. In the beginning, there is no current in the wire. In the beginning, there is no current in the wire. So what happens? This wire is connected to a galvanometer. Okay, what is a galvanometer used for? It is used to that is flow of current. Okay, to detect the flow of current. So now when you move the magnet, back and forth, current is induced in the conductor. So electric currents are induced in closed coils when subjected to changing magnetic field. The phenomena in which current is generated by varying magnetic field appropriately called electromagnetic induction. This process by changing magnetic field and current is induced. Such process is known as electromagnetic induction. Next is what? So relative motion between a bar magnet and a wire loop produces a small current in the wire. When you move the magnet back and forth, then current is induced in the wire. There are 3 experiments which were demonstrated by the 2 scientists. What are they? One is experiments. This is said to be EMI, electromagnetic induction. Okay. Experiments of Henry and Faraday. Okay. Experiments of Henry and Faraday. Henry, that is Michael Henry, and there is Joseph Henry and Michael Faraday. These are the 2 scientists. So the first one, what he says. So suppose there is a coil. Okay. So there is a coil is connected to a galvanometer. A coil is connected to a galvanometer, and a magnet is made to move. Okay, a magnet is made to move towards a coil. Okay, towards or away from the coil. What will happen? So current is induced in the conductor. Okay, current. So when it is made to move towards it, so current starts flowing in the induced current starts flowing in the conductor. Here, induced current starts flowing in the conductor. So this is G is the galvanometer and I is the current. Clear? This is the first one. That means when there is a motion between the magnet and the coil, so current gets induced in the coil. Now second one, there are 2 coils. Instead of a bar magnet, they have taken 2 coils. So instead of a conductor, they have taken 2 coils like this. Now this is connected to a battery. So what will happen? This will become here. Yeah, current will flow in this way. Then what happens? This is that means when this is made to move towards the a current carrying coil is acting like a bar magnet. A current carrying coil is acting like a bar magnet. When there is a current carrying coil and which is made to move towards or away from the coil, what will happen? Current gets induced in the coil. Okay. Current gets induced in the coil. So this is the second one. Third one. Now, suppose there is one more coil now. So this is again connected to a galvanometer, and there is a second coil. Okay. So now what will happen? Then here the coil is now there's a tapping key here. Okay. There is a tapping key. So with the tapping key, what will happen? When you on the key, when you press for a moment, when you are going to press, the current will flow in one direction. When you release it, the current will move in the opposite direction. So that is how you can see the changing magnetic field. If you keep it constantly, nothing will happen. If the switch is pressed constantly, nothing will happen. So this will happen in the these 3 diagrams. Clear? Is it clear? The next is magnetic flux. Magnetic flux is denoted by what? Phi B. Okay. Magnetic flux is denoted by phi B. That is magnetic lines of forces. So this is the this is n cap and this is the angle. Angle is theta. This is magnetic flux. So what is magnetic flux? This is n cap is the line perpendicular to the surface area. Okay. So surface area is here. So what is magnetic flux? Magnetic lines of forces. Magnetic field lines. Okay. Magnetic field lines passing per unit cross section area. Passing per unit cross section area. Okay. Passing per unit cross section area. Okay, that is said to be what? Magnetic flux. So what is the formula? Phi B is equal to what? B dot A, which is also known as phi B is equal to what? B into A cos theta. Okay, what is theta? Theta is the angle between magnetic field and N cap. Okay, so we can also write B into A. So what is the unit for this? Tesla meter square. Okay, unit of this is what? Unit of this is Tesla meter square. Okay, is that clear? The magnetic field is measured in Tesla or it is measured in Gauss. Okay, so that is a formula. Now we are writing here B into A cos theta, or we can write Weber. Instead of writing this, we can write Weber, WB. Okay, Weber. If you want to write the full name. So this is the magnetic flux. Next is what? Faraday's law of electromagnetic induction. There are two laws. One is Faraday's law of electromagnetic induction. The second one is that is Lenz's law. Two laws are important. So we'll go with Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. It says that the magnitude of induced EMF in a circuit is equal to the magnitude of the induced EMF in a circuit of the induced EMF in the circuit is time rate of change of magnetic flux through the circuit. Magnetic flux through the circuit. Time rate of change of magnetic flux through the circuit. Okay. Now induced EMF is given by what here? So induced EMF is given by E is equal to minus d phi b by dt. E is equal to minus d phi b by dt. Negative sign indicates the direction of induced EMF. Here negative sign indicates the direction of induced EMF. Okay, the direction of induced EMF means the induced EMF is exactly opposite to the direction of the changing magnetic flux. There is a meaning of that. If there are n number of turns in a coil, okay, so if capital N is number of turns of the coil, then what will happen? What is the formula? E is equal to minus n into d phi b by dt. Okay, minus n into d phi by dt. So if there are n number of turns, we use this formula. Okay, so just copy this. So we have Lenz's law and conservation of energy. Lenz's law and conservation of energy. So it says that the polarity of induced EMF, is such that it tends to produce a current which opposes the change in magnetic field, which produced it. is produced. Okay, so I'll take a simple example here. See here, there is a wire like this, and this is the magnet. Okay, north pole and south pole of the magnet. There was no current in the wire. When the magnet is made to move back, forward and backward, or relative motion, then what happens? Current got induced. Okay, there was a, because of the changing magnetic field, current got induced. When the current got induced, around it there is a magnetic field again. This magnetic field started repelling this magnetic field. This magnetic field started repelling this magnetic field. So this is about, the Lenz's law. Clear? So now what will happen now? When a magnet, suppose this is the north pole and this is there is a coil here, north pole and coil. So what happens when the magnet is made to move? What will happen? Current will start moving in the anti-clockwise moment. This is ACW. Okay, anti-clockwise, and we get a north pole. He says that we get a north pole. Similarly, suppose when a magnet is made to move away from the magnet, then what happens? So, so here, south pole is formed. Here, a south pole is formed. A south pole is formed. Is that clear? So that is said to be the clockwise. This is said to be the clockwise movement. Okay, we have anti-clockwise. When the magnet is made to move towards the coil, then current will flow in anti-clockwise and a north pole is formed. And when the magnet is made to move, north pole of the magnet is made to move away from the coil, then what happens? The south pole is formed and the current will, induced current will flow in the clockwise moment. Okay, or clockwise direction. Okay, so this is dotted one. Clear? So this is how he explained. Lenz has explained. Now the question was, the question was yeah. So now, so here what happens? Now he explained. Suppose conservation of energy means what he told here. Like suppose suppose how the explanation was given. If suppose south pole is formed.